Yeah, hi all. Good morning. Welcome to Devops demo class. Yeah, I am Sheikh Gayas, trainer for this course. Please go on mute. Yeah, please go on mute. Yeah, myself, Sheikh Gayas, trainer for this course. So I have 8+ years of IT experience, and I completed around 15 batches of training on DevOps and AWS. So here our course duration will be 3 months. Okay, more than 3 months it will take. So daily we are going to have 1 hour session from Monday to Friday, and on weekends we are going to have interactions. Okay, so one-on-one interactions will be there on the weekends. Okay, so before starting actual introduction about the DevOps, let's check what is the agenda for the today's session. So this is today's agenda. So here, first we will start with the course content. What are the things we are going to cover in our 3 months duration, and then we start why we need DevOps in SDLC. Okay, how what is the use of DevOps in SDLC? Then we'll discuss about cloud computing. What is the necessity of cloud computing? How the cloud computing will help in our SDLC. And after this, we are not going in any technical discussion for today's session. And these are the support you are going to get from us. Okay. So what we will do is from Monday to Friday, you are going to have regular classes from in the morning session, 1 hour, and in the weekends we are going to have interaction sections with everyone. Okay, with every student, whoever the part of our training, with them we are going to have interactions means whatever we covered in that particular week on that topics, if there are any doubts, and on these topics, how we have to prepare for interviews, what are the um, things in which concepts we have to focus more in the interview point of view. All these things we are going to have interactions in the weekend. Okay, so in the weekend there are no classes, means no new topics are going to be covered. It is like a revision and recap, like that. Okay, so after this we are going to have interview question discussion at the end of every topic. Okay, here we are having a different modules. We are going to cover different modules in our course. So at the end of every module, we are having 1 hour session about the interview questions. Okay, so once you completed the course, you are going to get a resume preparation support, mock interviews we will conduct. And here, if you complete this 3 months course, it will be equivalent to 4 years of experience. Okay. So today we will start with our actual agenda. So coming to the course contents. So in our total course duration, we are going to cover. These are the topics we are going to cover. So here we will start with the Linux basics, because some of them, some of the students will join from non-IT backgrounds also. For that purpose, what we are doing is we are starting with the Linux basics, because we need a Linux. So in our total course, we are going to work on Linux servers. Okay. So for that reason, we are going to start with the Linux basics. And this Linux basics will start from the very basic concepts to advanced concepts. What are the concepts we need as a DevOps engineer? All these concepts will cover in the Linux basics. Okay, so here we'll cover about different types of Linux flavors and Linux file system, and how can we change the permissions, and how can we stop the services, how can we install the packages. All these things we are going to cover in the Linux basis. See, these are some of the topics. In addition to this, we will cover some other topics also in the Linux. Okay, so it will take around 8 to 10 classes, up to 10 classes, up to 8 to 10 classes. We'll cover Linux basics. Okay. So after this, after once we complete Linux basics, which are required for our course, we are going to jump into actual DevOps course. Okay. So coming to the DevOps, here we are going to cover different tools like version control system like Git, and we are going to cover continuous integration tool Jenkins, and containerization tools Docker and Kubernetes. These are the containerization tools we are going to cover, and configuration management tool we will cover Ansible and Terraform. Okay, from the configuration management point of view, we will cover Ansible and Terraform. So these are the topics we are going to cover from the DevOps point of view. Okay. So in the DevOps point of view, we'll start with the version control system. Okay. That is one of the popular version control system is Git. Okay. So we'll start with the Git, and here what is a version control system means. So we know in any organization, in any software organization, we are going to have developers. Okay, we will going to have developers. So these developers, what the developers will do? Developers will develop the code, and that code we are going to maintain with the help of this version control system. Okay, so from that point we are going to start our course. So if you see the software development life cycle, so the different stages in any software development life cycle is so let's start with our SDLC. So SDLC is nothing but software development life cycle. So if we see the software development life cycle, to start any project, let us consider we have to start a new project. Okay. So what is the project? What is the meaning of project? Project is nothing but development of an application. Okay. So what are the responsibilities of any organization is to develop an application. Okay. To develop an application and to maintain the application. So these are the responsibilities of any organization, software organization. Okay. So to develop the application, again, we are going to divide into different phases. So if you want to start the development of our application, what we have to do is we have to do the planning for our project depending on our requirement. We have to do the planning. Okay, planning will be the first phase before start of any project. So any application. Okay, here always a project means we are trying to develop one of the application. That is the meaning of project. Okay, so application is what are any one of the applications. So what is application? So application is nothing but, so let us consider IRCTC. IRCTC. Okay, so we know we are having some website for IRCTC. Similarly, we have Amazon.com e-commerce website. Okay, Amazon. So for Amazon also we have some website. Okay, so these are nothing but the applications. These are the applications. How we got these applications? IRCTC, Amazon, these applications. So here to construct, to develop this particular application or any application. Okay, if you want to develop any particular application, we need planning for that particular application. Okay, so what is the meaning of planning? So planning means if you see any one of these applications, IRCTC website or Amazon website, we are going to get different pages, different features will be there. Okay, different pages will be there, different categories will be there. Okay, so all this information, all these, we need planning of all these categories, we need planning of all these pages. Okay, we need planning of all these features. Okay, so that is the initial requirement while we are starting any project. Okay, any application. Okay, so the first phase in our software development life cycle will be planning. Okay, once we completed our planning, we have to implement according to our planning. Okay, so let us consider we are going to develop some XYZ application. Okay, we are going to develop some XYZ application. For this particular application, planning is completed. Okay, planning, that is the first phase. Planning of our application is completed. Okay, once the planning is completed, what is the next step? What is the next phase? Okay, so the next phase in a software development life cycle is the development of the code depending on the planning. Okay, so here we completed planning. Okay, we completed planning. Means the planning is a requirement for our application. Whatever the application we are trying to develop, we are trying to construct. Okay, for that application planning completed. Once we completed the planning, the next phase will be the development of the code for our application or project. Okay, so this one, it again, the development of the code depends on the planning, depending on our plan. Means how many pages we need, what are the features we need in our application. Okay, what are the features we need in our application, what are the so depending on these features, depending on this requirement, we have to develop the code for our project or application. Okay, so the next phase will be in our software development life cycle. The next phase will be development of the code. Okay, so development of the code. So in the development of the code, we need developers. Who will develop the code? Who will develop the code? Developers are going to develop the code. Okay, so we have to provide the requirement for our developers. So depending on the requirement, developers are going to develop the code. And here in a software development life cycle, we are having a sprint model in the development phase. Okay, so sprint model means one sprint equal to it is around 2 weeks. We can say our developers are going to work on the sprint model. Okay, here one sprint equal to it is 2 weeks. One sprint equal to 2 weeks or 10 working days. So we can say it like that. Okay. Now what the developers will do is on every sprint, they are going to have some targets. Okay, before the start of the sprint, they will have some plan. Okay, they will have some plan to develop the code, for a certain feature. Okay, so we already discussed in our application, in our project, we are going to have different features. Okay, so on every sprint, developers will have some planning to develop any one of the feature from the requirements. Okay, from the requirements. So as the developers are going to work on the sprint basis, so at the end of every sprint, developers are going to release the versions, different version. Let us consider on first sprint, sprint one. Okay, on first sprint, developers are going to release version one. Okay. Similarly, on second sprint, developers will release version 2. Okay. Second sprint, developers will going to release version 2. So what is the difference between version 1 and version 2? So version 1 is going to have some features and version 2 is going to have some additional features, whatever the features we have in version 1. So on top of these features in version 2, developers are going to introduce some additional features. Okay, like that on every sprint we are going to have different releases, different versions from the development team. So to maintain all these versions, okay, we are going to use version control system. Okay, we are going to use version control system. What this version control system will do is it will maintain the different versions of the code developed by the developers. Okay, so we are having version 1, version 2, like that. We are going to have n number of versions. All these versions information we are going to maintain with the help of version control system. Okay, so in our software development life cycle, after the planning phase, the next important phase is development and maintenance of the code. Okay, so how we have to maintain the code from the developers. Okay, so to maintain the code, we are going to use version control system. Okay, so we are having different tools for version control system. So like we are having Git, and we are having a Bitbucket, and we are having SVN, Subversion, like that. Different tools are there. Okay, we are having a Bitbucket and SVN. We are having different types of tools for a version control system. So out of this, Git is a very popular. Okay, so we are going to cover the Git, that is one of the popular version control system from the basics to advanced topics. Okay, so here in the Git, what we are going to cover is how can we install Git, and how can we create different branches, how can we merge the branches, and if we get any merge conflicts, how can we resolve merge conflicts, how can we work with remote repositories. Okay, so remote repositories are necessary to maintain the code from the different developers. So here we are going to discuss how can we create remote repositories and how can we maintain the remote repositories. All this information we are going to cover in our uh, course. Okay, in our course we will cover Git as version control system. Okay, so once we got the code, what is the next phase? What we have to do? Okay, once we got the code, we have to work on to this particular code. Okay, what is the work means? We have to compile the code, we have to build the code, and we have to perform the deployment of the code. Okay, so in software development life cycle, we completed planning and we completed a development of the code. Okay, once we completed development of the code, the next phase will be to compile our code and build our code. And once we build the code, we are going to get artifacts from our code. Okay, we have to maintain these artifacts and we have to deploy our code. Okay, so these are the next phases in our software development life cycle. So in the next phase, once we got the code from the developers, to work onto this code, okay, to work onto this code, we are going to introduce one of the continuous integration tool. Okay, this is known as a CI tool. Okay, CI is nothing but continuous integration tool. So what this a continuous integration tool will do is a continuous integration tool will get the code from the source code management, that is version control system. Okay, so as we know, we are having code in our version control system. This code will be taken by the continuous integration tool and it will compile the code and it will do the code coverage analysis and it will perform the build operation and it will generate the artifacts. Okay, so all these operations are going to be done by continuous integration tool. Okay, so we are having different types of continuous integration tools like Jenkins, and so we are having a Team City and we are having a Bamboo. So like that, we are having different types of continuous integration tools. So out of this, Jenkins is very popular, and we are going to cover Jenkins in our course. Okay. So coming to the Jenkins here, we are going to cover the different topics like we start from the basics of Jenkins, means how can we install Jenkins, and how can we create a different projects with the help of Jenkins, creating the projects and running the jobs and creating master slave configurations, creating Jenkins pipelines, okay, and email notifications. How can we secure our continuous integration tool? And we are going to discuss different types of plugins. So all these things we are going to cover from the continuous integration point of view. Okay, so here we are going to cover Jenkins. It will take around 12 plus classes. Okay, so 12 to 15 classes it will take. So this is the next tool we are going to cover in our course. So once we got the artifact, so if you see here, with the help of a continuous integration tool, what we are doing is we are going to work onto our um, that is a code, and once we work onto our code, we are going to get the artifacts. Okay, so up to now what we did is here is we developed the code. Okay, so we developed the code here. Development of the code is completed. Okay, and then we, with the help of continuous integration tool, we got the artifacts. Okay, so here we got the artifacts. So with the help of continuous integration tool, that is Jenkins, we used the Jenkins to get the artifacts. Okay, so here what is the here what we got is we got artifacts. So we have to deploy these artifacts. Okay, so we can deploy these artifacts into our target servers with the help of different tools. Okay, so we are having some configuration management of tools like Ansible and containerization tools like Docker and Kubernetes. With the help of these tools, we can deploy our artifacts. Okay, So next phase will be, once we got the artifacts, we have to deploy our artifacts into deployment servers. Okay. So for this next phase will be deployment. So in the deployment phase, um, we can use different tools. Okay. Like Ansible or Docker or Kubernetes. With the help of these tools, we can perform the deployment of the code. Okay. So once we completed Jenkins, next we will start with the containerization tools. So we are having different types of containerization tools like Docker. So what is the necessity of Docker here is, here in any organization we are going to have different environments. Okay, we will have different environments like dev environment and testing environment and prod environment. Okay, so now in the development environment, what is going to happen is, developers are going to develop the code, and they will test the code, and they will deploy the code into their dev servers. Okay, and similarly in the testing environment also, so the same code, whatever the code we have from the developers, the same code is going to be tested in the testing environment. And once the testing is completed, next we are going to have pre-prod environment and prod environments. Into these environments, our code is going to be deployed, and we our code will come into live. So these are the different environments we are having. Now let us consider our code is working seamlessly without any issues in one of the environment. Means, so let's take one new phase. So in the dev environment, our developers are going to test the code, and in the SIT environment, that is a testing environment, the same code is going to be tested. Whatever the code we have, the same code is going to be tested in the testing environment. Okay, and once the testing is completed, the same code is going to be deployed into deployment servers. Okay, into deployment servers, into prod environment. Let us consider this is pre-prod or prod. So let's take as a prod environment. Okay, now in the dev environment, let's consider for our application, we need some configurations. Okay, so we need configurations means for our application to run seamlessly without any issues, we need JDK. Okay, Java 8. Let us consider Java 8. We need. Okay, Java 8 we need for our application, and in dev environment we are using Java 8 to test our application. Okay, so whatever the code we got for that code to test in dev environment, we are using Java 8. Okay, so as our requirement is Java 8, so our application, let us consider our application runs successfully. Okay, application is successfully executed. Okay, our application runs without any issues. There are no issues with our applications in the dev environment. Okay, now, so once it is successfully runs in a dev environment, we assume that our application, our code is running as per our expectation. So we can move our code. We can give sign off to our code to the next environment. Okay. So that's why we got the sign off and we moved our code to the next environment like SIT or UAT. Different types of testing environments will be there. So to the next testing environment, we moved our code. Okay. So, but in testing environment, there is a configuration change. Let us consider we are using Java 7. Okay, we are using Java 7 in the testing servers. So one thing here you have to remember is in every environment, we are going to have deployment servers. Okay, so different deployment servers. That is environment specific servers will be there. So we have to consider the configuration changes of these deployment servers in every environment. At environment level, we have to consider the configuration changes. Okay. So for our application, we need Java 8. In dev environment, we are using Java 8. So our application runs successfully. So we got the sign off to next environment. Okay. So we moved our code to the testing environment, but in the testing environment, the servers are using Java 7. Okay, let us consider our testing servers are using Java 7. Okay, so what is going to happen for our application? Definitely our application is going to fail. Okay, our application will fail. Okay, so to debug this, so what is the reason for failure of our application? There is a configuration change. Okay, there is a configuration change. Actually, we need Java 8, but in the testing environment, we are using Java 7. Okay, so even though there is no change in the code, so whatever the code we have in the dev environment, the same code we are using in the testing environment also. Okay, even though there is no change in the code, our application is going to fail due to this configuration change. Okay, so this is one of the drawback with the if we don't use containerization tools. Okay, when it will happen if we don't use containerization tools means Docker. What are the different containerization tools? Is a Docker. Okay, like a Docker containerization tools like Docker. Docker is a containerization tool to create the containers. We can use Docker. Okay, Docker. So if we don't use containerization tools, we have to take care of the configuration at every environment, whether we are testing our code in dev environment or we are testing our code in a testing environment or we are deploying our code in prod environment. In every environment, we have to take care of the configuration changes. So if there is a change in the configuration, even though there is no issue with the application, okay, even though there is no issue with the application, with the code, okay, application code, our application is not going to be successfully deployed. Okay, because there because our application code, our application depends on the configuration changes also. Okay, I need a Java 8 for my application, but I am using Java 7. That's why our application is going to fail. When this will happen? If there is no Docker, if there is no containerization tools we are using. Okay, so to mitigate this, to avoid like these situations, we are going for containerization tools. Okay, what the containerization tools will do is, so with the help of these containerization tools, we are going to create images. Okay, we are going to create images with the help of containerization tools. So what is an image is? Image is a combination of actual our application code. So where we are getting the code? We are getting the code from our developers. Okay, so this image is the combination of application code plus configuration changes. config requirements. Okay, so config changes, or we can say dependencies, libraries, binaries, whatever we need for our application to run seamlessly. Okay, all the requirement configurations will be included with the image itself. Okay, in the image itself, we are going to get the code and configuration changes. So what is the configuration change? In our example, we need Java 8. Okay, so we need Java 8. So this image itself consists of Java 8. Okay, so our image, if we get the image, this image is going to have our application code and Java 8, which is required for our application to run seamlessly. Okay, so like that, if we use a containerization tools, we are going to get images. Okay, we are going to get images. So these images consist of code and configuration changes. Once we have the images, what we will do is we are directly going to use these images. Okay, so we are going to use these images for the deployment in any environment, whether it's a dev, test, or prod environment. Whatever the environment, what we will do with the Docker is we are going to get the image and we are going to deploy the image. Okay, so if I use the image instead of deploying my code directly into dev environment, what I am doing is I am going to use Docker images. Okay, now I am using images, Docker images in every environment. Okay, whether it is a dev or testing environment, also I am using images. Okay, and in prod environment also I am going to use images. From where I am getting these images? I am getting these images from the Docker, from the containerization tools. Okay, so if I use images, then no need to bother about the configuration of the environment. Okay, means if I am using Java 8 in a dev environment, I am using Java 7 in testing environment, and I am using some Java X version, okay, in prod environment. Java X version I am using in prod environment. Okay, so if you see here, in every environment, I am using different types of Java. Okay, so even though there is a configuration change, if I use images, then if my image works seamlessly in one environment, then I can give guarantee that the same image will be deployed without any issues in other environments also. Okay, so how can I give that assurance? Because my image itself consists of code and configuration requirements, configuration changes, libraries, binaries, dependencies, everything my image consists of. Okay, so that is the advantage of containerization. Okay, so if my image runs successfully in one environment, then the same image I can deploy in any environment without any issues. Okay, because my image itself is having the required configurations for my application. Okay, for my application, the required configurations are there in my images. So that is the advantage with the Docker, and that is the advantage with the containerization tools. Okay, so so here what is the image means? So whatever the artifacts we got from the continuous integration tool. Okay, so we already discussed we are going to have continuous integration tool. From that continuous integration tool, we are going to get artifacts. That with the help of that artifacts, we are going to create images. Okay, how we are creating images means we are getting the artifacts from the continuous integration tool and we are creating the images. Okay, so once we got the images, with the help of Docker, we can deploy our application into the respective environment, into respective deployment servers. Okay, so once we completed Jenkins, we'll start Docker, which is one of the popular containerization tool. Okay, so under Docker, here also we'll start from the basics. Okay, so what is a Docker? How can we install a Docker? And Docker architecture. Okay, and some basic stuff about the Docker, and we'll discuss the advanced topics in Docker also, like Docker networking and Docker volumes, Docker swarm. Okay, and Docker compose. All these concepts we are going to cover in the Docker. Okay. So for this Docker, it will take around 17 to 20 hours. Okay. It depends. It will vary from 17 to 20 hours to complete the Docker. Okay. So this is the flow we are going to cover in our course. So in the Jenkins, what we are getting in the Jenkins. So if you observe here, so in the Git, we are getting the code, and in the Jenkins, we are using that code to get the artifacts. And once we got the artifacts, we are going to convert these artifacts into images. Means we are developing the images from these artifacts, and we are deploying these artifacts into deployment servers. Okay. So similarly, we are having Kubernetes, which is one of the popular containerization orchestration tool. Okay, so there is a difference between Docker and Kubernetes. What is the difference between Docker and Kubernetes is? So Docker is just a containerization tool. With the help of Docker, what we can do is we can create the containers only. Okay, just we are going to create the containers. Okay, and once we create the containers, so let us consider we have some hundreds of containers. Okay, we have some hundreds of containers. So to maintain all these containers, to check the health information of these containers, and to scale up the containers, scale down the containers, to perform all these management activities, we are going to use Kubernetes. Okay, Kubernetes is one of the popular containerization orchestration tool. Okay, so in the Kubernetes, once we completed Docker, we will start a Kubernetes. Here also we'll start from the basics. How can we create a Kubernetes cluster, and how can we add nodes? How can we add masters to Kubernetes clusters, and how can we maintain these nodes? So all this stuff we are going to cover, and how can we create containers? How can we maintain containers? And how can we attach volumes to the containers? And here we will discuss about persistence volume clients and persistence volumes, and ingress controller, and different types of services we are going to cover. And So these are the different topics: horizontal pod auto scaling, config maps, and health probes. So all these informations, all these topics we are going to cover in the Kubernetes. Okay, so it is also it will take around 12 to 15 hours for Kubernetes. Okay, so once we completed Kubernetes, then we'll start Ansible and Terraform. So this Ansible is one of the popular configuration management tool. So what is the necessity of a configuration management tool means? So let us consider we are having some 1,000 machines. We are having some 1,000 machines in our environment. Okay, so 1,000 servers are there. Let us consider, and for this 1,000 servers, we have to do some patching. Okay, we have to perform some patching, or we have to install some software. So like that operation, if we want to do for these 1,000 servers, we can go for a configuration management tools. Okay, so let us consider we are going to install some extra software in all these 1,000 machines, and to install our software in one mission, let us consider it is taking 30 minutes. It's taking 30 minutes. Okay, So for one mission, if we do manually, if it is taking 30 minutes for 1,000 missions, how much time it will take? So for 1,000 machines, 1,000 servers, it will take around 500 hours. If we do manual operation, okay. If we do manual operation, it will take 500 hours, okay. But if we use configuration management tools like Ansible, okay. So if we use the configuration management tool, what we will do here is we are going to have one Ansible manager or master, and this we are going to connect our Ansible master with this 1,000 servers, and simply if we run some script in the Ansible master, our installation, our software, whatever the patches or whatever the new installations we need, these are going to be completed within 30 minutes. Okay, just we have to run some script and it will install the required software in 30 minutes in all the servers. Okay, so if you observe here, if we do manual operation, it is taking 500 hours, and if we do the same operation with the scripts or with the configuration management tools, it will take only 30 minutes. Okay, so that is the advantage with configuration management tools. Okay, so now we'll discuss about Ansible. So how can we install Ansible? How can we work with Ansible? Are these topics I will cover in the Ansible. Okay, and after this, we are going to start cloud computing. So here we are having Terraform also. So once cloud computing is completed, then we'll start Terraform, because there is a dependency between this cloud concepts and Terraform. Okay, that's why after Ansible, we are going to cover AWS. So that is Amazon Web Services. So in the Amazon Web Services, we are going to cover that is EC2 Elastic Compute Cloud, and AMIs, load balancers, auto scaling, and S3, Glacier, VPC, CloudWatch, IAM, RDS, SNS, CDN. All these topics we are going to cover in the Amazon Web Services. Okay. So what is the AWS? What is the AWS? So AWS is one of the cloud platform. Okay. So what is the necessity of cloud computing before going to AWS? What is the necessity of cloud computing? So be like in interactive session. Okay. So whether you are following or not, be in the interactive phase. So what is the cloud computing means? So previously we are having on-premises infrastructure. Okay, on-premises infrastructure, and we are going to have data centers. So every data center is the combination of the required servers, storages, firewalls. So all the physical components we are going to maintain in the data centers. Okay, before cloud computing, all the organizations are using data centers to maintain their on-premises infrastructure. Okay, so here if we have on-premises, if we don't have cloud computing, if we are implementing on-premises, we are having some types of drawbacks, like that is on-premises. If we are using on-premises infrastructure, okay, we are having the different drawbacks, like maintenance of our infrastructure. Okay, maintenance will be difficult. Okay, so we need to maintain all our servers and all our storage devices, firewalls, everything what we need for our organization, everything we have to maintain. Okay, and uh, here another important concept, if we don't have a cloud computing, is um, that is scale up of our application. Okay, so if we are using on premises, let us consider we are using 1,000 servers, 10,000 servers are there. Okay, for our application, we are using 10,000 servers. Okay, and suddenly there is a spike in our traffic. Okay, so means if we consider any one of the e-commerce websites, they are going to have some offers on festive seasons. Okay, so in these seasons they are going to get spikes. Okay, it means on some special occasions they are going to have some offers, and traffic to that particular websites are going to increase suddenly. Okay, so we are maintaining, let us consider we are maintaining 10,000 servers as a normal day traffic, but if the traffic increases, then we have to maintain some 20,000 servers or 50,000 servers or 1 lakh servers. Let us consider we are maintaining, we need 1 lakh servers for our traffic to maintain on special occasions. Okay, but again, in the normal days, if so, we increased our servers from 10,000 to 1 lakh servers. But in the normal days, again the traffic is going to reduce. Okay, the traffic is going to become normal. So 10,000 servers are sufficient for us. Okay, 10,000 servers are sufficient for us. Again, what we had to do previously, we increased the servers from 10,000 to 1 lakh. Again, we have to decrease the servers from 1 lakh to 10,000. So it is feasible. It is not feasible. It is not feasible. Okay, so means if we are using on-premises infrastructure, the scale up of services, scale down of services is difficult. Okay, maintenance of our traffic is somewhat irregular. So like that, we are having many disadvantages with the on-premises infrastructure. So we are going for cloud computing. Nowadays, most of the organizations are moving into cloud computing. Okay, so in the cloud computing, what we are doing is, so whatever the services we need for our organization. Okay, so whether we need a servers or storage devices or a databases or some other services, whatever the services we need for our organization to run seamlessly, we are going to hire our services. What we are doing in cloud computing is we are going to hire our services depending on our requirement. Okay, so if our traffic is high, we can hire uh, 1 lakh servers. If our traffic to our application is less, we can reduce the servers. How can we reduce the servers? Whatever the servers we have, we hide, we can release the servers. Simply, we are going to release the servers. Okay, so scale up and scale down of our services is easy if we use cloud computing. Okay, and another advantage with the cloud computing is maintenance. There is no maintenance burden. If we have to maintain data centers, we have to take many risks. Okay, we have to maintain the buildings, we have to maintain all the infrastructure, we have to hire many people to for the maintenance of our infrastructure. Many burdens are there. So if we go for cloud computing, all these burdens are going to be reduced. So due to these advantages, nowadays most of the organizations are moving into cloud computing. Okay, so we'll discuss all these things in the Amazon Web Services. We are going to cover under AWS. We'll cover EC2, auto scaling, load balancers, and how what are the different types of load balancers? How can we create load balancers, and what are the different types of storages we are having? How can we store our data? All these things we will discuss. Okay, these are the topics we are going to cover under Amazon Web Services. So it will take around 12 to 15 classes for Amazon Web Services. So once we completed AWS, then we will move to that is a Terraform. Okay, so here in the, if we use Amazon Web Services console, we can manually create our servers, we can manually create our auto scaling, we can manually create our storages and our databases. All these things we are going to do manual operation. Okay, And if we want to automate all these operations, okay, what operations we are going to automate? Creation of the servers, creation of the databases, deletion of the servers, auto scaling of the servers, everything we can automate with the help of Terraform. Okay, so once we completed AWS, we'll discuss Terraform. So, okay, so this is the agenda for our course. Okay, so these are the topics we are going to cover in our complete course. So that's for today. So if you have any doubts, you can ask now. And once we completed our course, we are going to have interview, that is resume preparation. We'll support for resume preparation, and we will have mock interviews. Okay, so we'll conduct around 2 to 3 mock interviews from the real-time experts. Okay, so so this is the agenda of our course. If you have any doubts, I can ask now. The regular classes will start from tomorrow, that is Monday. The class timing will be from morning 7 to 8, daily 1 hour. The classes will be from Monday to Friday, and on weekends, only interactions. No new topics are going to be covered. Only interactions will be there.
Sir, weekends means Sunday or Saturday, sir?
Saturday, only Saturday.
But can you try because we are in working hours, sir.
Yeah.
Saturday is not a holiday for us.
Yeah, Saturday means in the evening we are planning 6 to 8 like that.
You try to plan. On Saturday we'll come to from college. It will around 6:30, sir.
Okay, then okay, depending on okay, by considering different things, so we'll change the timing also. No, on Saturday timing is not fixed one. We can change it. Okay.
Okay.
But
Okay.
from Monday to Friday, that is fixed. Morning 7 to 8.
Yeah, thank you, sir.
Hello.
Yes.
Yeah, my question, how you doing today? My name's Gene. Yeah, you said the class is Monday to Friday. You said 7 p.m. to what time?
7 a.m. IST. 7 a.m. IST.
Yeah, because the time is no matter, but right now on my time right here it's in 35 a.m. in the morning. So I don't know if the time gotta watch. It's the time's very different. So right now it's 1:35 a.m. in the morning. So it's night time here.
Yeah.
Also, how long is the course gonna take? Is it about 3 months or 2 months? How long is that gonna take, please?
Yeah, 3 months. Course duration is 3 months.
Oh, you said 3 months?
Yeah, 3 months.
Okay. Okay, that's good. That's all I got. Yeah, that's all I got. Thank you.
Okay, thank you.
Sir, can you put that syllabus, sir, word format?
Yeah, I will WhatsApp the syllabus also.
Okay, thanks, sir. Tomorrow agenda is Linux, no, sir?
Yeah, from tomorrow onwards, we are starting from 7 a.m.
10 a.m. Linux. Tomorrow.
Yeah, basic stuff.
Basic
So
stuff.
here, basic stuff means what we are going to do is we are not going to install any softwares in our local machine. So we are going to get the server from the cloud, that is Amazon. So for tomorrow's session, we'll discuss how can we create account in Amazon and how can we get the server from the Amazon. So this server on this cloud server only, we are going to do the practice. Okay, we're not going to install any software in our local machines. We'll install all the softwares in the cloud servers and we'll do the practice on the cloud servers only.
Okay, thank you, sir.
Hello, sir.
Yes.
Pawan here. If I miss some few classes, then
Yeah, so we are providing recordings also. At the end of every class, we are providing recordings also.
okay. So Monday to Friday timing is fixed, but Saturday is also conducting.
Saturday evening time. The timing we have to discuss with the students. After discussing with the students only, we'll fix the time on Saturdays.
Okay. Okay. Thank you, sir.
Can we leave the session, sir?
Yeah, if we don't have any questions, so you can leave.
Thank you, sir.
Another question I have, do we need to have a background in Linux before we take this class?
No background is required. That's why we are starting from the basics. Okay. So that's why we included 8 to 10 classes as basic classes, basic requirement, whatever the requirement we need to learn the remaining DevOps tools. First 8 to 10 classes will cover.
Okay, thank you.
Hello.
Yes.
Sir, did you explain the real-time scenarios and live projects?
Yes. So we are not going to follow any theory classes. Every class will be like a real time only. Whatever we are doing in the real time, the same concepts we are going to discuss on every class. The class will be like an interactive session. Okay. So we are going to ask for screen shares to the students. Also, we'll give assignments to students. So everything will be in real time scenarios only. So if no doubts, we can close the session.
Yeah, again, my name's Gene. I gotta send you I gotta test you some question on the WhatsApp because I need to see exactly what time that gotta be matched with my time here.
Okay,
Because
sure.
right now, right now, it's too late right here to wake up every day and
Sure. Yeah, sure.
So yeah, so if maybe you gotta send me the course by the recording or so I talk to you on the WhatsApp. We see how we can do.
Okay, sure. We'll discuss on WhatsApp also.
Okay.
Okay, thank you all. Thanks for joining the session. I'm going
All right.
to. Yeah, thank you.
Thank you.
Yes, someone is speaking.